2, 3, 4. Kailua, well, I'm stuck here in Kailua, and I'm not really sure, if it's safe out in Kailua. I'm just not sure. Wanna go out with all of my friends. Wait till this thing ends now. I need to see them for a minute. Well, the world is tough with this thing in it. Got me saying, ooh, ooh, I wanna see them home. Ooh, we wanna roam. Ooh, ooh, oh, I gotta tell you, I just gotta go. Kailua. I wanna go out in Kailua, but I'm not really sure, if it's safe out in Kailua. I'm just not sure, Okay, that's a tough one. That's a challenge to sing in that key. All right, hey everybody, Mr. Pat here. Kailua, Hawaii. Kailua, Oahu, more appropriately. Boys and Girls Club, coming at you again. I missed my lesson yesterday, so I'm putting it up today. That was my take on Havana, only we personalized it to Kailua, what we're going through now. All right, so welcome. We're going to go ahead and jump into our lesson. It's kind of a trippy lesson. You know, you're looking for a different way of classifying numbers. It's very basic skill driven, but it's got some interesting sides to it. And then the coming days after this, I'm going to add to it with a tripped out exponent thing. Show you this stuff called Mersenne prime. Okay, before we get started, I want to show you something from a couple days ago. The last lesson, I know from looking at the views, not a lot of people have looked. You might want to do that. It offered you a way to make like a gift for mom or a gift for a friend, and we showed you how to measure and create this net of a pyramid. Wasn't that hard to do. And I made this one out of 8.5 by 11. And then I said, you know, remember you're folding it up. And you end up with a cool little thing that you can mess around with decoration wise. And I suggested string art. So what I did was I did it on one side. So if you forget what the string art is, go back and look at that lesson. And then on this side here, I used the straight up and down of this triangle face, and I made the right angle here, and I made one on the right side, one on the left, and it came like that. I just wanted you to see it's kind of cool. Not really easy to do. It took about 5 minutes a side. But if you did that and use your imagination, and then if you have cutout areas that you could like put something inside and see in a very decorative way. Or you could do something like this and you could use color and whatnot just to show you these things look a lot cooler. I mean, this is fine, but you get some decoration on it, it's even better. And you could even reverse this where you use this, and this is the axis and the curved part is on the inside. So the curved part's reversed and the two together would make like an oval opening. So play around with that if you want to. Just if you go through making this, you might as well make it special for however you're going to use it. So I wanted to show you that. Cool. All right. And again, how to make the basic is the lesson, I think lesson number 11. Okay, so it's on YouTube also. All right. Okay, well, here we go. So what we're going to do is we're just going to work with about 3 or 4 special numbers, or separate numbers, sorry. And what we're going to do first is, there's like 3 steps. So number 1, we are going to find all the factors of 90. So the number I'm picking to start with is 90. I just randomly picked one. So there's a bunch of ways to do that. You know, you're listing all the ways to multiply to get 90. So some students go like this, or 1 goes in, 90 goes in. You can list it 2 at a time like that. That works. Some students go 1. I know 2 goes in. I know 3 goes in. But you can, I don't particularly like this method. You're finding 2 factors at a time. So if you know 1 goes in, 1 times 90, those are both factors. So you're going to list them all. What Mr. Kent likes to do is I list them in pairs. So I go 1 times 90. Always start with that 1, don't forget it. That's a pair of factors. I know 2 goes in. So that's 2 more factors. So your job is to find all of those you can. Use a calculator, your divisibility rules, whatever. Okay, I know 3, most people could go 3 times 30. With 4 you can try, but it's 4 times, was that 22.5? That doesn't work. We only want whole number factors. Whole numbers. And I'm going to show you a cool trick. Say you're hunting factors and you don't have a calculator. Look at this one right here. Take the 3 and double it. But take the other number and take half of it. Bam. So you got another one. So you take that number and multiply it by 2. Take that number and divide by 2. So one that it won't find them all, but sometimes it finds one you might miss. If it ends in 0, it can be divided by 5. And it turns out 5, 40, 18. You could try the trick I just showed you. This time take half of the even one. Okay, and double the odd one. Right there. So 1, 2, 3, 4 didn't work. 6, 7's not going to work. 8, nope. Okay, so that's it. So these are all the factors. So whenever we start this special classification, step 1 is find all the factors out. Okay, so what I'm going to do now is I am going to erase this, but leave the factors. We're using 90. I'll put it right up here. Okay, step 2 is add the factors together. Add them all up, but do not add the original number. So you're adding everything here up, but you're not going to add the original number. So you add the 1 part, but you don't actually add the 90. So we're going to add all the others, but not the 90 itself. Okay? So 3 and 6, 9, 10, 12 here. let's see, 45 and 30 is 75, plus 10 is 80, plus, so that's 90. 5 plus 10 is 15. 18 plus 9 is 27. So 90 plus 12 is 102. Plus 15 is 117. Plus 27, 144. So this adds up to 144 if I did it right. You can use a calculator for that part. That's probably not a bad idea. Okay, so far so good. So you first list all the factors, all of them. Don't miss any of them. Second, you add all of them up, but you don't add the number you started with. Okay. You've got all this down on your paper. Okay, part 3, the last thing. And I wrote a 2, that wouldn't be very good because it's part 3. Oh, Mr. Pat. Okay. Compare this sum. If you forgot, sum means the answer to an addition problem, to the original number. So there's 3 classifications that can happen. So when we look at 144, that's the sum, and we compare it to 90, okay, we can see that 144 is bigger. So the sum is bigger than the original number. So when we add all the factors up, it's more than the number itself. So there's 3 ways to classify a number. We're classifying 90. Having more than you need, something that's above and beyond. I got extra. There's a word for that. It starts with an A, and I'll just tell you it's called abundant. Like an abundant supply of something is something you got plenty of. Okay, so that's what in this coronavirus thing we were wishing we had an abundant supply of PPEs for the healthcare workers, but we didn't, unfortunately. So in some states we do. Hawaii, we're lucky like that. Okay. So what's happening here is 90, the factors of 90 are more than 90 needs. It's bigger than it. So we say that 90 is an abundant number. Okay, that is how you classify. So we say, okay, 90 abundant. All right? So we're going to go through the same process with a different number and see what happens. This has a real profound algebraic and number theory explanation, implication coming up in the next couple of days. For now, it's just kind of a cool thing to learn. Okay, so our new number this time, we're going to start with the second example. So example 2, let's use 51. I'm going to go ahead and write it up here. So same exact thing. First, we find all the factors. And we always start with the number 1 times 51. Now, it's not even. So I check. 5 plus 1 is 6. Since 3 goes into the sum, 3 will go into that number, believe it or not. So 3, you're not sure, you come over here and you go, oh, right, check that out, 17. Okay. And then you start, you can't do the half thing because both of these are odd, so it doesn't divide. So you think 4, no, all even numbers won't go in because it's an odd number. So you really only got to worry about 5. Nope, not a 0 or a 5. 7. 7 times 7 is 49. 2 left over, it ain't going to work. Dude, that's it. So this is an easy one. Okay, so we found all the factors of 51. That's it, just these 4. Okay, we're going to add them all up, but we don't add the number itself. So we're adding 1 plus 3 plus 17, and that's only 21. So this sum is only 21. You can always use a calculator to help you find factors. Okay. So our sum is 21. Our original number was 51. This time, the factors are less than what we started with. Last time, 90 had 144, more than it needed. We said it was abundant. 51 doesn't got enough. So there's a word that starts with the D that stands for not enough of something. And I'll just tell you, that's called deficient. So 51 is called a deficient number. If you don't have enough grades on Jupiter grades, you get a deficiency sent home. A report saying you're not doing well enough. And hopefully that's never happened to you. Okay, so here you go. So if the factors are plenty, more than you need, that number would be abundant. If the factors are not up to that number, if they're less than it, then it's called deficient. And numbers are going to be one of those things, okay? All right, so we're going to do one more. What shall I pick here? Let's go example 3. Pick another even number, 28. Okay, so work your magic. Do that dividing thing. 1, hope you remember that. Pat yourself on the back if you did. This time going to be 28 even. So 2 goes in. You had half of 28, you'd have 14. You can take half of 14 and then double the 2, or you can just know your times tables. 4 times 7. 5 won't work. 6 times 4 is 24, and then the next one's 4. That won't work. 8 times 3 is 24. Nope. That's it. So those are all the factors of 28. Not too bad. So again, part 3, we add them all up, but we don't count our starting number. So 1 plus 2 is 3, plus 4 is 7. 14 plus 7 is 21. Add those together, right, check that out. It look familiar. So when you add all the factors of this stuff, you get 28. And look what the starting number was, 28. That rarely happens. By the way, I'll throw a word at you, a French word. Adding all the factors but not counting the number itself is called the aliquot. A-L-I-Q-U-O-T, the aliquot sum. All the factors except not the number itself. Don't forget that 1 though, it does count. So this is a special case. So when we had 90, factors added up to 144. When we had 51, the factors added up to 21. When we had 28, the factors added up to 28. Okay, you guys all right? So, we're going to summarize this. If you have more factors than you need, abundant. 90 is an abundant number. If you have less factors than you need, this is smaller than that, it's called deficient. If you have exactly the same, the sum of the factors is equal to your starting number, those are rare, then you have what we call proudly a perfect number. So when you ask people, what's a perfect number? They're not going to know. They're going to tell you their favorite number or whatever. Perfect number is when you add all the factors up, except the number itself, and it equals exactly the number you start with. That's what people are looking for. So we're going to jump in on Monday and Tuesday to this thing called Mersenne primes. It's actually this just incredible computer-driven, tripped-out search and number theory for the next perfect number. So you know a perfect number. That's what a lot of people don't. You just got one. Okay? One thing I want to throw out, I'm not going to do another example. That is enough. Perfect number when the factors add up exactly. The alicosum adds up exactly to what the number you started with was. Okay, one more thing. I'm going to do one really quick without following through with it. Okay, let's say you had something like 36. So you got, whoops, I got a mess. So you got your 1 times 36. I'm just going to give you these if you don't know them already. So if you're searching for this, there's lots of factors. You can already tell it's going to be abundant. Because 18 plus 12 is 30 plus 9 is 39. But what I wanted to show you was, if you ever get one of these things that are perfect squares, like 4 or 16 or 25, 36, 49, you not only don't add that, you only add one of these 6s, because 6 is a factor of 36. You don't add them both up. So if there's ever double the same number within a thing, perfect squares, that only happens on these perfect square numbers. Okay? You guys saw those when you were doing all your square root stuff. Okay? And we'll look at that more later too. Okay? Just wanted to show you that. Okay, that's it. That's awesome. Okay, that's some super cool stuff. Great basic skills lesson. And then it has the application you're going to see related to this guy, Father Mersenne from France, a few hundred years ago, came up with this super tripped out cool thing. All right, let's see if we can finish off with our unanas. Pardonnez-moi, moi. Kailua, I wanna go out in Kailua, but I'm not really sure, If it's safe out in Kailua, I'm just not sure. Wanna go hang out with my friends? I gotta wait till this thing ends. Wanna see them for longer than a minute. The world is tough with this thing in it. And saying, ooh, we're stuck right here at home. Ooh, we all wanna roam. Ooh, I just gotta tell you that I gotta go. Na 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 na. All right, I will see you next time. Thank you as always, Mr. Pat, Kailua, Hawaii, Island of Oahu, Boys and Girls Club. Stay safe, take care of each other, and soon you will be out and about and hanging with all your friends. Wait till it's safe to do it to protect you and everybody else you love. Okay? Take care, everyone.